Hey everyone, welcome to the first ever video in the CAIA in Action series. I'm Yusuf, a data scientist at Silos, and today we'll be going over the GMPOS Arla demo. So at Silos, we've developed the Reinforcement Learning Automation Platform, or Arla for short. Arla powers GMPOS, which is our gas master plan optimization suite. GMPOS is built to optimize every stage of the gas value chain, from production to storage, transportation, all the way through to exports. The suite includes several intelligent agents that work seamlessly with our GenAI-powered control tower. The control tower not only provides valuable features like real-time alerts, root cause analysis, and agent recommendation explanations, but it also complements the reinforcement learning agents themselves, ensuring you have a fully optimized and potentially autonomous decision-making system. Today, we'll be exploring how the agents and the control tower work together, and I'll demonstrate the system by interacting with Arla directly, much like I would Siri. So let's take a quick look at the dashboard itself. On the very left, we have our workflows, our reinforcement learning agent alerts, and our reinforcement learning agent recommendations. Both the alerts and the recommendations are driven and generated by the reinforcement learning agents themselves. The control tower collects them and uses generative AI to explain them to us in a much more understandable way. So let's take a look at the workflows really quickly, and we have several different ones. Each of these workflows was designed by our subject matter experts. So first, we have the gas storage manager. The gas storage manager is responsible for optimizing supply distribution. The production scheduler aligns production with demand. The export planner workflow is designed to maximize export profitability. And the maintenance planner schedules maintenance for field equipment. The supply demand planner balances supply and demand, and the gas supply master optimizes supply distribution. Let's take a look at the overall structure of our gas network. Hey Arla, what does the gas network structure look like? Great, so our dashboard is now populated. So Arla says, our gas network consists of 5 gas fields, gas field number 1 to gas field number 5. 3 storage facilities, storage field number 1 to storage field number 3. 3 transportation routes, transport route number 1 all the way to 3, and 4 export regions, export region number 1 all the way through 4. Each stage is optimized to ensure efficient operations. Now, I'll ask for details about the gas fields. So here, I'll ask, hey Arla, can you provide details about our gas fields? Great. Now notice we have much less information on our dashboard because we're focusing in on the gas fields themselves. So Arla's response is, certainly, we have 5 gas fields. Gas field 1, 2, 3, 4, and 5, all with their titles. These fields are actively monitored to contribute to the network's total gas output. Great, but now I want to check out the storage facilities that were mentioned earlier. What storage facilities? Great. Arla's response is, our 3 storage facilities are storage facility number 1 with a capacity of 5 million cubic meters, storage facility number 2 at 4 million cubic meters, and storage facility number 3 with 3 million cubic meters. They ensure a smooth balance between gas supply and demand. Now let's look at some workflows. I'll start with how we manage gas distribution. So if you recall, we had our several different workflows, and I'm going to visit this gas storage manager workflow. So I'll click on the execute workflow button. Now we started our workflow, and it automatically populates with pre-built prompts regarding this specific workflow. So here will be the prompt, hey Arla, start the workflow to optimize gas supply distribution. Great, now Arla knows exactly what to do. Arla says, I've initiated the gas supply distribution workflow. Here's the current forecast for gas demand across residential, industrial, and export sectors. Residential, we have 50 million cubic meters. Industrial, 40 million cubic meters. Export, 60 million. And we're asked, how would we like to redistribute the supply? But I'm not convinced yet. I have another follow-up question. So I'll continue the workflow and ask, hey Arla, what's the current storage capacity in our facilities? I need more information to make a better decision. So we send this question to Arla and our response. Currently, storage levels are as follows. Storage facility number 1 is at 85% capacity. Storage facility number 2, 75%. And storage facility number 3 is at 90% capacity. And we're asked, would we like to redistribute gas to avoid overflow? Great. Now, I'd like to move on to a different workflow. I want to work on the production scheduler. So, I'll execute the workflow. So Arla says, I've started the population scheduling workflow. Here are the current production rates. Gas field 1 at 235 million cubic meters per day. Gas field 2, 192 million cubic meters. Field 3 at 125, and so on. Then we're asked, would we like to adjust production to align with demand? Well, before doing that, I'd like to continue the workflow. So I'll check their production versus the forecast to give me more information to make better decisions. So I'll send the question to Arla. So I asked, is current production sufficient to meet tomorrow's forecast? And Arla responded, the demand forecast for tomorrow is residential, 55 million cubic meters, industrial, 45 million, export, 65. The current production is slightly below demand. Would you like to increase production from gas field 2 or redistribute from another field? So now let's take a look at how we handle alerts and recommendations from our different Arla agents. So I'll ask Arla, hey Arla, show me the active alerts for our gas network. Great, let's see what's going on. Arla says there are currently 2 active alerts, pipeline pressure drop on transport route number 2, and a storage overload at storage facility number 3. Let's dig deeper into the pipeline pressure issue. So I'll click on my alerts panel and handle that alert specifically. Keep in mind that the gas transportation scheduler is responsible for sending us this alert. So I click on handle alert and let's send this to Arla. Great. The root cause of this pressure drop on transport route number 2 is a compressor malfunction at gas field number 4. The malfunction has caused a 25% reduction in gas output, resulting in lower pressure across the pipeline. Interesting. Let's take a look at the other alert. So I'm going to click on handle the alert, send it. Hey Arla, why is there a storage overload at storage facility number 3? Arla's response, the root cause of the storage overload at storage field number 3 is a supply chain delay on transport route number 1. The transportation bottleneck has caused gas to accumulate in the 3rd storage field, exceeding its storage capacity by 10%. Okay, I'd like to handle both of these alerts. So I can click on the handle all alerts button or just ask Arla directly myself. So I'll say, hey Arla, what are the corrective actions for these alerts? Great, so now Arla is telling us how we can handle the situation in the best way possible. For the pipeline pressure drop, I recommend prioritizing repairs on the gas field 4 compressor to restore production capacity. Alternatively, we can increase output from gas field 2 to temporarily compensate for the shortfall. Now for the storage overload, I recommend rerouting gas from storage field number 3 to storage field number 2, which currently has 25% capacity available. Interesting. So now we have a really good starting point for our decision-making process. Now let's take a look at the agent recommendations. So I'll say, hey Arla, show me current RL recommendations. There's 3 current recommendations for optimizing the gas network. Increasing gas flow from field 1 by 10% to meet rising residential demand. The second is to adjust export routes to prioritize export route number 4, which is the Philippines, due to higher market prices. The third one, to reduce storage levels at storage field number 3 by redistributing gas to storage field number 2 to avoid overcapacity. And if at any time we want to look at these directly, we have the agent recommendations panel. And again, each of these recommendations is sent to us by one of our different agents. The first recommendation, to increase the gas flow, came from the gas production optimizer agent. The second one, to adjust export routes, came from the export profitability analyzer. And lastly, the recommendation to reduce storage levels at the 3rd storage field came from our gas storage planner. So all of these different agents are looking at different parts of our network and sending us different recommendations and alerts. And the control tower is where they all come together and we can catch everything at a glance. Hey Arla, explain the first recommendation. Great. The recommendation to increase gas flow from gas field 1 by 10% is based on the rising residential demand due to a cold front, forecasted over the next 48 hours. Increasing the flow from gas field 1 will ensure adequate supply without impacting industrial or export sectors. Great. Hey Arla, explain why we should adjust the export routes. The recommendation to adjust export routes to prioritize the export route number 4, the Philippines, is driven by current global gas prices, where the market price in the Philippines has increased by 15%. Redirecting exports to export route number 4 will increase revenues by 12%, compared to maintaining the current route to export route number 2, which is Thailand. And that was the Arla GMPOS demo. As you've seen, our GenAI-powered control tower and the reinforcement learning agents work together to provide real-time optimization across the entire gas value chain. These tools ensure that decisions are made with precision, transparency, and efficiency. If you'd like to learn more about how Arla and GMPOS can transform your operations, visit us at silos.com. In future videos, we'll be covering some of Arla's other features, like the operator override or updating agent optimization goals and constraints. Thanks for watching.